All right, it's my pleasure to introduce this session today. We have been working very hard on this for the last couple of months. So we have a plenary theme session that is different to the other themes that you will see later today and tomorrow. This one was inspired by the early career researchers, and they came up with this theme because they felt that it is good because we have such a large contingent of early career researchers here today. So the theme is, as you can see, called Nurturing the Next Generation of Data Science Leaders. And I'm pleased to introduce the two moderators today. Then they will come up to the stage and introduce the speakers, who will give you some short talks followed by a panel discussion. So happy to introduce Mr. Oluwole Olajit. Olawole is a PhD student at the University of Ibadan, Nigeria, specializing in machine learning and medical imaging. His research focuses on using deep convolutional neural networks for detecting and classifying sickle cell anemia in pediatric chest X-rays. A strong foundation in data science drives his innovative approaches to enhance SEA diagnosis and management. Oluwole is distinguished data scholar, recognized for advancing data science for societal good. Passionate about AI in healthcare, he aims to bridge medical research and technology, particularly in hematology. At the LASU Research Fair in October 2024, he won 3 awards: Best in Physical Sciences and Engineering for the abstract, overall Best at the conference for the abstract, and overall Best oral presentation. Oluwole aspires to improve SEA understanding, healthcare outcomes, and health policies in Nigeria, integrating AI into medical practice. Then we also have Ms. Miriam Lakabua. Miriam is a PhD student at the University of Queensland. She is a recent recipient of the Uzima DS Pilot Project Grant, awarded to support innovative health data science projects aimed at impactful change in East Africa. Her research focuses on mental health conditions and the critical role of societal determinants of health, with a unique emphasis on African communities and other understudied populations. Driven by a commitment to address disparities in mental health, Miriam seeks to deepen understanding of how both genetic and environmental factors contribute to neuropsychiatric disorders. By integrating social determinants into this framework, she aims to advance current research on mental health disparities with the ultimate goal of improving health outcomes for marginalized populations, often overlooked in mental health studies. Please give a warm welcome to welcome these two up to the stage. Thanks.
Ladies and gentlemen, we are here for a very important session, which is nurturing the next generation of data science leaders. I would begin off with a word of thanks to Rolanda and the Data Science Initiative Africa for actually allowing us to host our own session. I believe it's a very important thing to nurture the next generation of data science leaders. I mean, they hold the future for tomorrow. Is that right? Any ECRs in the house? Any ECRs in the house? Make some noise. All right. A brief about the panel, or even before I get into that, just made some notes that I would like to read from. I get inspiration or borrow inspiration from my mentor. Unfortunately, he hasn't made his way here, but he's by the names Professor Shegun Fatumo. Science is plagued with a lot of challenges right now, but I think some of the ways we can lessen the challenges that it is facing is through nurturing the next generation of data science leaders. He, in one of the motivation sharings that he does with a group, this is what he said. As early career researchers, it's crucial to build a solid foundation of rigorous research practices avoid shortcuts, double check your data, and always ensure your findings stand the test of scrutiny. So it's important to do the science, but I think how we also do the science and ensuring that we do it right is very important. And that's the essence of this theme that we are co-chairing with Dr. Olwole. It was birthed out of a collective effort from all the early career researchers. So it's not solely our views, but a collective effort from everyone over sessions of preparations on Zoom calls and everything. I would like to introduce or call my co-facilitator to take you through the session's goals and the format. Thank you.
Good morning, everyone. Thank you, DSI Africa, and thank you, Rolanda, for the mentoring. And we appreciate this opportunity, and we're not taking it for granted. Quickly, because of our time, I'll just go through the goals, the reason why we've decided to have this session. Number one, we realize that strategies for building a diverse, supportive ecosystem for ECRs in data science is lacking. What do I mean? We want to encourage diversity and inclusion, that is creating opportunities for underrepresented groups to engage in data science. Then mentorship and training. We also want to be offered targeted programs, funding and resources for ECRs. We need funding also to actually project the ideas, to actually bring the ideas that we have into the limelight. Then we want a collaborative platform that is establishing a network that connects ECRs and with our senior researchers, the industry leaders, and the policy makers. Then we also thought of a support system in ensuring access to scholarship, fellowship, mental health resources to retain young talents. The last point, we realized that a lot of our young early career researchers, just all of a sudden, you just find out that they move out from the academic section and go to the industry. So those are the things we looked at. Then also opportunities for interdisciplinary collaboration and knowledge sharing. So one of the points here is cross-section collaboration, that is bringing together experts from fields like computer science, epidemiology, and public health to solve complex problems. Then knowledge exchange, organizing conferences, workshops, and hackathons to encourage idea sharing and skill building, which is one of the, I think one of the, I would call it strengths of DSI Africa, because I think that's what we started when we came here. We were able to work together on projects. And we also need more platforms like that. Then global partnership also, leveraging international collaborations to gain diverse perspectives and technical expertise. As much as we think that we are data scientists in Nigeria or in Africa as a whole, there are still some things that we are still lacking. We are still a bit far behind in the world of data science. Then want to address, we thought of addressing the digital divide and improving access to data science resources. That is infrastructural development, that is expanding the internet connectivity and access to computing resources in underserved regions. Then open source tools, promoting free and accessible software and data sets. Then also we looked at capacity building, that is investing in digital literacy programs to equip local communities with data skills. Then advocacy, raising about the importance of data science in health among decision makers. So these initiatives collectively aim to transform Africa's health sector through innovative, equitable, and impactful applications of data science, ensuring sustainability and inclusivity in addressing health challenges, and also helping us as ECRs to actually get more involved in the world of data science, because it becomes so painful. I think I was talking to one of our prof this morning, and we were like, a lot of our young ones leave Africa and go to the Western world. And that's why we are losing a lot of strength. We need everybody back home also so that we can also improve Africa. So those were the things we thought of. And what better way can we learn this if not for our seniors that have been in the field You've been out there, you've seen the risk, you've faced everything we can think of, policy making and that. And we need to be groomed. So that's what has brought every one of us together. And that's why we picked this topic. I will hand over to my co-facilitator, then she will take over from there. Thank you.
So our sessions format, we have 5 speakers and each has 8 minutes. They'll begin with short talks and later on that will be followed by a panel discussion where we have some structured questions to ask them. And I'll begin this off by introducing the first speaker, Professor Benjamin Aribisala. Professor Benjamin Aribisala is the program director for Datican, and he's a professor of computer science and a Fulbright scholar. He has over 28 years of teaching and research experience, and he has worked in the UK, in the USA, and in Nigeria. In particular, he has worked in Newcastle University. He has worked in the UK, he has worked in the University of Edinburgh, and in the Lagos State University in Nigeria and the University of Chicago in the USA. He obtained his PhD degree from the University of Birmingham in 2006, and he has served as Dean of the Faculty of Science at Lagos State University and head of the Department of Computer Science. He is a data scientist, and his research focuses on the application of data science to the medical domain. Please welcome you all please join me in welcoming Professor Benjamin Aribisala.
Thank you very much. Okay, the technical team, yeah. Oh, okay, yes, okay. So I want to start by appreciating the organizers of this particular meeting. It's a great pleasure to be here. In particular, I appreciate NIH and the DSI team. I am so grateful for the opportunity to come and make a short presentation in this particular session. And I appreciate the early career team members as well for inviting me. Next slide. Okay, so the focus of this, I have just 3 items to discuss. I know I have maximum of 10 minutes, so 8 minutes ideally. So I want to talk about a little bit, just 2 or 3 slides about my career overview. And then I talk about the introduction to career journey as somebody who is aspiring to be a data scientist, but I will tilt towards the academic environment, the ecosystem where I work, and then resources required to climb the career ladder to be a data scientist in the university. Okay, and thank you, Miriam, for that nice introduction. I started my career as a mathematician. I so much loved mathematics, but at some points, I wanted to see the application of mathematics. I was bored with looking for X and Y without putting, something with application into it. So that was my first motivation towards migration to computer science. And so from mathematics, I did, master's degree in computer science. And during my PhD, even during my mathematics, I became so interested in the medical application of computer science. And then I proceeded to obtaining my PhD in the UK at the University of Birmingham, and where I focused on skin cancer. And so that was a big move towards the data science subfield of computer science. Some of my okay, so as my academic qualifications are presented, I have a couple of professional qualifications, and I'm still learning, and you can't stop learning. Every opportunity, more so those of us who studied maybe in the 80s or 90s, if you don't move with the speed, the extremely dynamic and technological advancement, then you'll be left behind. And you can't just actually be on a point. You have to be moving, because if you're at a point, then people will be moving. And so you discover there is retrogression. So no stagnancy at all. So I've been doing a lot of professional qualifications, or a number of them, in data science related field. As we are aware that data science actually was called, data mining at some point. And so I did some certifications, and then I've done some other training. In particular, last year, I had to, even though I've been teaching machine learning, but I saw the need to learn more. So I had to do some professional qualifications. And I really want to echo that to early careers. If you are in a university or research institute, apart from the academic qualification, you need the professional qualifications a lot. So I'm going to be talking about that because that helps you to acquire the hands-on skill. So in the area of work experience, I've worked in Nigeria, in the UK, and the US, 3 continents. So I've been privileged to work in the universities listed. I just want to say that, as Miriam has nicely said, so 2 years ago, I was in University of Chicago as a Fulbright scholar. So I've been privileged to hold different positions in the university environment. In 2014, I was head of department of computer science. And then in 2018, I was dean of faculty of science, and I joined the governing council of Lagos State University in 2018 as well. So I've served as the director of ICT, director of Center of Excellence for Research in Sagasom, in Sagasom Research, and I've worked as Vice Chancellor of a university. And currently I sit on the Lagos State Research and Innovation Council in Nigeria. So now looking at introducing the early career, career journey. So how should you embark on the journey? Or how has it been for me? So, and that's why I started with mine, so that we can now try to tilt a little bit. And everybody is different anyway, but there is a path that will be very helpful. So the title of the topic I've been giving is Data Science, nurturing data science leaders for African health research. So I just made those points. What do I think you need? A number of things, but focusing on the hard skills and the soft skills and the experience. So you need the hard skills. You just need those. Those are the first thing, but you can't do with those alone. So you need an environment, to acquire or to develop your soft skills, and then you need the experience. So the hard skills, as we are aware, these are tangible and technical skills that you can acquire by going to a university or any institution to the school. And they are specific for each profession. So as a computer scientist or as a data scientist, you need to get some qualifications. And then the soft skills are what we describe as intangible, but they are transferable. And I'm going to list a number of them. And there are so many. It's impossible to cover all of them in this particular short presentation. So looking at the hard skills, so what do I think you should do? Yeah, you need a degree. If you see the field of data science, it's not only for those who have background in computer science. Physicists can do it. Mathematicians can do it. Any scientist. But so you need a degree, in a course that is related to data science. So BSc Mathematics, BSc anything related to science that will help you to understand who a scientist is actually. So you need, if you want to be in academic environment, or if you want to deepen your understanding, then MSc and PhD degree, I recommend, a PhD degree in data science specifically. And then professional qualifications, I mentioned them. And now research interest in health science, because, the good thing about data science is the multidisciplinary nature. So it brings people from different area or fields of life. So, but if we are focusing on building African leaders in health sector, so you can't just be a data scientist, because data science, has application all over. So, but your focus has to be in that health sector. So for me, medical image analysis, computational neurosciences, neuroscience, and clinical condition. So there must be a problem you are solving. So there must be a problem that, that can help the environment or help humanity. I always say that all my research efforts are focused towards improving quality of life and increasing longevity, making us to do well even at old age. So in the area of soft skills, as I said, this is non-exhaustive, but you need passion for whatever you do. And that is in everything we do. If you do any job you don't love it, a little challenge, you are out of it, And I want to say that, never have any problem with failures. Failures are part of us. You fall down, you stand up again. So your paper is rejected, then you have to work on the paper. Don't think that somebody is frustrating you as an early career. I always tell my students that I've been through so many about, learning from others, but it always energizes us. It forms your experience. It helps you to know the reality of life. I said to my students, if you write a paper and you submit it, immediately the next thing, maybe tomorrow or that same day, accepted. Then what have you done? You have wasted your efforts by publishing in a predatory journal. So peer review will always come with a lot of things. And then, those skills, so try and don't be afraid of failures. Don't hate criticism because it's part of life. Quiet time, that may be strange, but I remember when I was doing my PhD and I was really struggling for almost a year in Birmingham, and it seems all my algorithms were into working, and I've done all the reviews. I've done everything. Professor Ella Claridge will say to me, Ben, don't read again. No reading. Just go and think. And I was surprised. Do I need a time for thinking? And alas, she was right. So we need that time to reflect on things, and there is a lot in human brains, if only we can task it. So, and there are other skills, I know time is of essence, but you want to be a leader, you have to be a visionary leader. You have to think about the future. You have to think where you want to see yourself, in the next 10 years, in the next 15 years, in the next 20 years. So you must have the vision, because that's what will help you to channel your efforts and energy and even plan your time towards achieving those. I've listed a number of them. Time will fail us to look through them one after the other. So career journey, I mentioned, hard skills, soft skills, and then the experience. Yeah. Data, as we have been told, and we are aware, I'm talking to data scientists, we know that this is the best field. And so there are applications all over. So you can, but how do you acquire the experience? Yes, you can be in industry, but if you want to be in academic environment, or you really want to, you just need an environment. You need an environment. Academic environment is what I advocate. And, Wale mentioned that the people are moving from academic environment, to the industry. And we need to do something about that, because we are the people who develop those codes. We are the people who solve the problem there. So as an early career researcher, you need the academic environment. You need to attach yourself to a research institute. Our applications must be in health sector, and you can climb the career ladder as you progress in your career. So the ecosystem, in particular where I work in a university, currently Lagos State University, and what I have here will be similar to most universities in Africa and even in the world. So we have, in human side of the ecosystem, we have 5 key areas. So we have the academic staff, generally speaking, we just say lecturers, in Nigeria. We have the admin staff, and we have the students, external stakeholders, and we have the alumni. And all these work together, to make the system. So information flows from one, to the other. And students, we are, student-centric, if you like. So everything we do is towards research and towards building capacity to make sure that our students in Lagos State universities, acquire the right skills. We have a population of about 35,000 students in Lagos State University. So we are a big university, and we are still growing. And we have directorates that are academic in nature, and we have non-academic directorates. So, but everybody works together. And I must say that our alumni arm is very, very strong. So they even donate to us. You know, this is the outlook of every university, and we have them. They are even part of our governing council. So we have some of our old students in that particular category. So for those who are interested in having a career in academics, so I just put the 7-step ladder here. This is what obtains in Nigeria, and I know it's not the same all over, you know, but in Nigeria, I joined, you know, in 1995 with a BSc degree. So you are called a graduate assistant. And then as you obtain your MSc, you're an assistant lecturer. And 3 years, or you have your PhD, then you become lecturer 2. So we have lecturer 2, lecturer 1. And you have senior lectureship and associate professor, which is readership in the UK. And you can, you know, attain the height of a full professor. And typically, each of these, you need publications and you need to mature by way of spending 3 years in a particular cadre. So typically it takes about 18 years if you work hard. It's not the same for everybody. So resources required to climb the ladder, as I make efforts to round up, you know, a number of them, you need the environment to work, however smart you are, you just need the environment. You need those journal papers, you know, you need to attend conferences like we are here, a lot to learn from a meeting like this. You present your work and you learn from others. I say to my students that, you know, it seems to be a big problem in some part of the world that people tend to hide what they do, you know, but the world has really moved. If you don't want anybody to see your work, then in the end, what you are doing is rubbish, because a lot, you know, you could gain from others. And maybe if you hide your work too much, by the time you want to publish, you will discover that it's obsolete and nobody is interested in your work. So attending conferences, you know, peer review, you know, you need the computational resources. You need electricity will be strange to some people, but in Africa, that's very, very important. And I must say, echo something, and that's mentoring. Mentoring is a big problem, you know, in our country, but, you know, we need that a lot. You need a role model. You need somebody who will be guiding you. I mentor a lot of students, and then we need people to actually mentor you. And at a meeting about, you know, 4 weeks ago, we were talking about mentoring in Nigeria, and there was a question, who should actually identify the mentee? Is it the mentee who should look for the mentor, or the mentor to look for the mentee? It depends on the way you say it, but we concluded that the mentee should look for a mentor. You know what your needs are, and you can identify somebody that you want to mentor you. And so I want to acknowledge and appreciate, you know, NIH and all the universities who have worked, you know, and I must say, I want to put it on record that I sincerely appreciate NIH, and in particular, Laura, for the excellent job that you are doing. I remember, you know, last year at the meeting, you know, we came up with these suggestions about how do we bring the early career researchers to even attend this meeting? And you took it upon yourself, and we can see the result. I appreciate you, and I appreciate your team for the excellent job, and all the listeners, you know, for being here early this morning. God bless you. Thank you.
Thank you so much, Professor Benjamin. Can we give him a round of applause again? Thank you very much for the inspiring speech. I will introduce our next speaker. So please, we still have the panel section, so, all right. Thank you very much, sir. The next speaker is Dr. Uriah Tegali. Uriah holds a PhD in virology and bioinformatics. She is the head of the data science at the Center of Epidemic Response and Innovation, focusing on the genomic epidemiology and evolution of the SARS-CoV-2 and arboviruses in Africa, along with associated impacts of climate change on transmission dynamics. During the COVID-19 pandemic, she optimized the assembly and analysis of the SARS-CoV-2 genomes from multiple African countries for outbreak response, which was pivotal in the identification of the Beta and Omicron variants of concern. Our research interests revolve around the genomic surveillance of infectious diseases, and particularly the use of genomics and phylogenetics within epidemiological and population scale data to reconstruct and track their transmission, dynamics, and impact. Can we please just welcome Dr. Tegali to take our speech?
Hello, everyone. Thank you so much for the opportunity to talk. So today I want to talk a bit about the topic, this very important topic, and more specifically about how to promote diversity and inclusion in data science for health in Africa. So a bit of an introduction about my career journey, but first to tell you that I'm from here, so welcome very much to this country. I always show this slide to show people where I'm from because it's very small in the middle of nowhere, but you've all made the journey here, so you know where it is. And if you haven't yet, please take some time to visit the country, walk around the city, maybe go to some of the nice beaches or mountains. So about my journey, so from having done all my schooling here in Mauritius, I then went to do my BSc at Yale University in the US, where I did a BSc in molecular biology, but also had some time, thanks to the liberal arts education, to do coursework in computer science, which was actually pivotal to my journey. Then I did a master's in applied biosciences and biotechnology. And there I worked in the lab for my project, and I realized I love biology, but do not like to work in the lab. So data science and bioinformatics was for me, and I joined Dr. Bechu, who may be around here at the University of Mauritius as a research assistant in cancer genomics. And this was then a node of the H3 BioNet consortium. And this is through this consortium that I then came to know about UK Zidane, where I then did my PhD in viral bioinformatics, which really shows the importance of these networks for career development, but also to promote this ecosystem in Africa. And after my PhD, I joined the Center for Epidemic Response and Innovation at Stellenbosch University, where I am now a senior scientist and head of the data science unit, focusing on phylogenomics and epidemiological ecological modeling. So CERI's mission, our institution, is to be at the forefront of epidemic response and innovation in Africa and to assist the continent to control our own epidemics and pandemics. Just about the ecosystem, we are within the School for Data Science and Computational Thinking at Stellenbosch. We also have our labs in other parts of the university, but we have a big data science unit, as well as a partnership with the epidemiological modeling, the South African Center for Epidemiological Modeling, SACIMA. So we are very data focused. And just to talk a bit more about that, we have several projects going on at CERI. Some are more lab focused than others, but all of them have a very big data component. So ranging from climate change to sequencing to population health, immunology and microbiome research. And we also are responsible for the DMAC activities of the Inform Africa project within the DSI consortium. So we develop scalable platforms to coordinate data access and harmonization for SARS-CoV-2 and HIV, ranging from genomic data, population health data, and also geospatial data. And then we leverage our omics experience to pair that with an NGS or next generation sequencing analysis platform. So my field of work is pathogen genomics, and this is a very big data field. So where we do sequencing from diagnostic samples, for example, when someone goes for a PCR test after flu or COVID infection. And yesterday we heard about the NCBI short read archive. These are the raw reads which we then assemble into whole genomes. This is the bioinformatics process. And then that goes into genomic epidemiology, which is my field of work. And it involves making the phylogenetic trees and looking at the evolutionary relationships between thousands of viruses at a global scale sometimes. So to do this, we very much take an integrative data analysis approach involving, as I said, the genomic data, but also the patient metadata. For example, gender, age, travel history, comorbidities, vaccination status, which we can pair with the genomic data, and then put into the context of epidemiological data, such as number of recorded cases, excess deaths, hospitalizations, etc. But more and more, it is important to also put that in context of population and environmental scale data, to look at demographics, air traffic flows, climate disasters, etc., depending on which diseases we are analyzing, and also ecological data, then taking into account the ecosystem aspects of infectious diseases, particularly for arboviruses. So this is some examples of our work during the SARS-CoV-2 genomic epidemiology, where we collaborated across South Africa and across South Africa to characterize variants of concern during the pandemic. And this is some of our work within the Climate Consortium, which stands for Climate Amplified Diseases and Epidemics, where we then pair this evolutionary analysis with epidemiology and ecology. Here I'm showing just two examples of this work. The first one in the middle showing our work on the impacts of climate change related human migration on infectious diseases. The objective there is to match our genomic surveillance data for viruses to the satellite tracking of large population migrations and see if there is a correlation. And so we use satellite imagery to quantify the numbers of people moving following a disaster, such as a flood, which we can recognize on satellite images. And then the associated genomic surveillance data, if there is an outbreak, can be used to link to that. And we also use big data and modeling to analyze air traffic flow and dengue transmission suitability, which we estimate from climate-based parameters to assess the dengue virus importation risk in Africa. So all of this is a big integration of various data sources. And this is a summary of what this ecosystem looks like at SERI. It's divided into several themes, such as genomic epidemiology, ecological modeling, and also including some AI. So on the picture, you can see in the different colors, either the data that we use in green and the models that we use in orange, yellow, or off-white. So including the phylogenetic, phylodynamic model, epidemiological modeling, and ecological models, and the outputs that we can get from that, which include estimates of risk of importation, as I just said, or quantifying relationship between the environment and viral transmission dynamics. And at several of these points, we can also use AI to facilitate these analyses. And this is our team at SERI. So the data science team is quite diverse, and this is how you get a successful data science team. There are people coming from ecology, others coming from GIS, geospatial analysis. We have computer scientists and AI scientists at various levels, so PhD students, postdocs, or even assistant professors. And as you can see, the women are quite importantly represented, so I'm very happy about this as well. And then we, in terms of partnerships, we've partnered recently with the African Institute for Mathematical Sciences, AIMS, in South Africa, to supervise AI in science MSc short projects in various fields related to the genomics of infectious diseases and climate change and AI. So just a word about the resources that is required to make a successful ecosystem for data science. First is the personnel, as I just showed you. We have a dedicated data science unit, and I think this is why we can really support this kind of work in various fields, so geospatial analysis, computer science, ecology. We also have access to large, powerful equipment, so reliable compute systems like the previous speaker mentioned. We adhere to an open data science ecosystem, which we believe helps the next generation of researchers in our group replicate analysis, but also promotes the ecosystem more broadly. And all our work is public on our GitHub page, for instance. we have to say thanks a lot to our funders because there are a lot of costs related to data analysis, even if we don't work in the lab. So data often costs money to generate or to buy, and cloud costs, computing costs. We have a huge scientific support effort in our institute. We have student support, early career development initiatives, and support for writing grants. So I've been very fortunate to be very well supported to write grants, which can then fund this kind of work. And we focus a lot on upskilling by promoting international conferences, workshops, both internal and external. And in terms of research funding, as I mentioned, I've been very fortunate to be challenged and pushed to put forward applications, and some of them come out successful. A lot come out rejected, obviously, but that's just the name of the game. So thank you very much, and looking forward to the discussion later.
Thank you, Dr. Tegali. Can we give her a round of applause again? Please, let's do it enthusiastically. Please, let's clap. It's not easy to stand on the stage to talk to people. I think I know it's not easy for me standing here this morning. So our next speaker is Dr. Joyce. I'm sorry, I don't want to murder the surname, but I'll try my best. Nakatumba Nabende. I don't know if Dr. Joyce Nakatumba Nabende is here. Did I try? All right. Is Dr. Joyce? Okay, she's here. All right, thank you. Dr. Joyce is a senior lecturer in the Department of Computer Science. She heads the Makerere Artificial Intelligence Lab, a research lab in the Department of Computer Science. She is a board member of the Data Science Africa. Her research interests are machine learning, natural language processing, and responsible AI. I welcome Dr. Joyce to the podium.
Recite your name. I was like, I hope it's Miriam doing the introduction, so it's easy. I can say thank you, Miriam. Now I have to say thank you, Oluwole, for the introduction. It's been tough. Yeah, good morning, everyone. Good morning. All right, thanks. Yeah, so I'm called Joyce, has introduced. I am going to talk about a bit about my journey, but also about the lab, because I think this is a session around mentorship. And so I'll just talk about the kind of mentorship that we do for students and early career scientists in the lab. So I'll, talk about that as well. So about me, my background is in computer science. I did my undergrad and my master's in Uganda, but from two different places. I started out in Mbarara University of Science and Technology, which is a university in Western Uganda, and then came to Makerere University to do my master's in computer science. I think when I started out, it was a bit early. That's when computer science was really starting out, and we were really learning around programming in Java and C. At that point in time, we didn't have Python like we have right now, so we were really starting out our journey many years ago. After which I moved to the Netherlands, where I did my PhD at Eindhoven University of Technology. And it was, I think, in Eindhoven that I was introduced to the world of data and looking at data. My research was around looking at process mining at that time. Because the Netherlands is very aligned with industry, it's very easy to get data sets. But at the point when I was doing my research, it was focused on data sets for processes and looking at simulation and looking at how human resources work. So my research area was around building process mining, data mining models, but for business processes. Then I came back and did a postdoc in Sweden at Gothenburg University, where I was looking at software development and microservices. Because of my background in computer science, I thought that was intriguing to look at how systems are developed end to end and the different subcomponents around software systems. Yeah, so that's my background. When I finished, then I came back to Makerere University to do my lecturing, and then took over the research lab in Makerere University, which was founded, I think, around that time that I was still doing my PhD. So it's been there for a long time now. We can be take the pride that we started to do machine learning as the lab in Africa. I wasn't there then. We had Dr. John Quinn, who was my PhD supervisor. Then we had Dr. Ernest Mwebaze, who some of you have met here. Then I took over and started to lead the research lab that has birthed another lab now, the Makere Health Lab that's led by Dr. Rose Nakasi. I bet that you have met also here today. Yeah, so the lab has evolved into a center. It's the Makere University Center for AI and Data Science. We are really focusing on building up excellence in AI research for accessible solutions. And we're trying to do this by solving real world problems. We focus on three main things as a lab. One is around the research, and I will speak a bit more detailed, not too much, about the research we do. We also focus on building capacity for MSc and PhD students, and then ensuring that when we combine the research with the students that are going on, we can be able to translate this into knowledge and enhance the impact through the different community collaborations that we have. So the research is a lot, as someone has said. Data science is multidisciplinary, so we try to have a multidisciplinary team as well in the lab. Our focus is AI for social good. It's something that we've learned to do. We focus on building systems end to end. When we started out the work, I remember the first time I got a grant and I was very excited of, yes, I'm going to do some work in NLP. And I thought it was very easy. I will wake up, open my eyes, and the data sets are there, and I start to build. It wasn't like that. I realized we didn't have data sets that we had to use for building out the work for the grant that I had won. And so we began on a deliberate journey of trying to understand, what does it mean to build a data set? What does it mean to build the models? What does it mean to talk to stakeholders, to understand the problem that they are interested in? And so most of our work is that end-to-end, that you're not just waiting for data to appear, but you participate in the data collection, you participate in curating, in labeling these data sets, in building out the models, all the way to developing and deploying them for end use. We've done work in agriculture where we have gone to the farmer fields, the expert fields. We are participating in the harvests and making sure that we know and value the data that's coming through. And so for many of the interns who come to the lab and they're like, oh, we are very interested in machine learning, we want to work. We're like, oh, don't worry. We have a very easy task for you. Next day, we're out in the field doing recording for voice. Or we're out in the field participating in a harvest, for example, for agriculture, because we believe that that helps them to appreciate where the data comes from, for which they use to build out the AI models. So our research is in those areas around health, agriculture, language technology, because it's important to keep preserving African languages, and environmental monitoring. And so there's a lot of work that we've really done that I won't go into for the sake of time. But what is important for me that I pick out is around the curation of the machine learning ready data sets, because we're always crying, we don't have data, but I want to point that we have at least made a deliberate effort to ensure that we have data sets publicly available, that people can really start out and build out on as they do their work, and through collaborations, I think as mentioned yesterday, like the Masakani Consortium. It's been really a deliberate effort as African researchers to try and build out these things by ourselves. So for the training and mentorship that we have, as I said, we do have the interns who come in to start to do their journey. They've probably done a bachelor's in computer science or a bachelor's in engineering, but they want to get into data science, and we provide a position for them to sit and start working. We've definitely been fortunate because of the funding received through NIH on our MAC data program, that we are training PhDs and MScs here, and I'm fortunate to have a feel of the work of many of the fellows that are part of MAC data that we are mentoring for their research. We've also got funding, I think, from IDRC and FCDO, who are funding 10 research labs on the African continent, and Makere is one of the labs that are being funded again to continue to train masters and PhD students. And then through the collaboration with APHRC, I know Dr. Agnes Chiraga will talk about that. We are also having a cohort of PhD students under the DSWB project, and then also Google. We've had funding for previous cohort of a PhD student and another PhD student, where they give award for 3 years for the student to really start and finish up their journey. So just to mention that as a lab, we are intentional to look for funding to support our students, because we believe it's something that I experienced when I went to the Netherlands and I was settled and I had funding. I didn't have to worry about that. And I believe it's the same space that we should try to provide for our students, even on the continent, that we can provide this space and peace for them to do their research without necessarily worrying about where the funding is coming from. So yeah, that always drives me as I try to move along in the lab. I like this because the lab is part of what we call Data Science Africa. I don't know if many people have heard about it, but yeah, we are part of Data Science Africa, where we do training and workshops. Our recent workshop was in Nyeri. We had the previous one in Arusha. It started out in the lab in Makerere, then grew to Kenya, and now we are moving places. And I believe next year we're going to be in Nigeria. We'll be in your country. Yeah, we're going to be in Nigeria. I like because we provide support for students, so master's students, undergrads who want to just be introduced to data science, machine learning. We pay for them to come. We have support to pay for them to come and learn. And we're also asking countries to be intentional in providing chapters for their different countries, that you don't have to wait for the big Data Science Africa that happens after 1 year, but in the different countries, we can be intentional to have these different chapters where training of students can go on in machine learning and AI. And then as part of the lab, we're part of something unique around Arua Guild. I don't know if anyone knows about that collaboration, where we have some universities in Africa and some universities in Europe collaborating together to form a consortium. So we recently have these clusters of excellence that were established, and I'm part of the cluster of excellence on AI. I think our leader is Stellenbosch University in Africa and Uppsala University in Sweden. And because we have many researchers that are part of this consortium, it's been a learning journey for us, for the students to understand the work that other people in the different universities are doing, because I think we have 5 African universities and I think 4 European universities. And so we have this thing called master classes, where we have each of the researchers coming in and being in one university, and then different students from other places connecting to this master class. So what you see here is students in our lab who are attending a masterclass given by Professor David from Uppsala University, talking about his vision of data science and modeling for football. I didn't know there was data science in football, but it is there. But it's like a new area that people were very interested in. And so we have different students in the different universities joining in a particular masterclass. And I thought this is important, that we always try to provide avenues for students to be introduced to new areas of research that they can pick topics from. We did give one on responsible AI, bias and fairness, because that's something I'm always very passionate about, that we build our models in a responsible way. So I think as we do this, I try to make sure I push responsible AI out there for the models that we are developing. Yeah, and then we have our weekly research seminars. We were fortunate to host Laura. I think I wasn't there, but I see the picture somewhere in my archives. Yeah, in the lab. So we want to thank you, Laura, for the support and, coming down to see what's going on in the lab. I think it's a good space because then we have students coming in to present. Don't worry, the stage at which your work is, we are always there to provide feedback. And we've seen many MSc and PhD students going in and getting feedback to improve their work. And that has really helped them to accelerate growth in the work that they do. Yeah, and these are just different collaborations. I thought it was a good slide to throw in. And we want to, I think, provide the resources. Yes, we have the personnel, a bit of compute. We're trying our best. What is important? Data sets, because that's always the issue that we start with as the students. And then providing support and mentorship for the early career scientists and students who want to do internship. And then the collaborations. Over time, we've built collaborations with different organizations in the country and outside the country. I think this is important, especially when students want to have the practical place for them to apply their machine learning in different areas, because it's multidisciplinary in nature. And so we want to thank all our funders over time, because this has really helped us to grow. It has really helped us to provide a base for students to come in, learn machine learning, go to different places. My principal always tells me, don't hold on to people, let people go. And I have been intentional to just make sure we provide the space for people to learn, for people to grow in the lab as they continue to do their work. Yeah, so that's what I wanted to provide and looking forward to the discussions. Thank you.
Thank you, Dr. Joyce. Can we give her a clapping ovation one more time? Don't worry, I'm sure you're wondering why am I coming up again. After this, don't worry, my co-facilitator will come up. I'm privileged to invite Dr. I'll try, sir, not to murder your name. Dr. Indiowu Makondo. Can you help me out with the first name, sir? All right, thank you very much. Okay, I will say Dr. Makondo. Thank you. He's a research manager at the IBM Research Africa, leading a team of scientists and engineers to conduct basic and applied research in the integration of knowledge, reasoning and learning, and natural language processing for various scientific and business use cases, and building AI systems and capabilities to contribute to IBM research strategy to infuse research into platforms and products, and localizing the capabilities through partnership in the African continent. He is also a visiting researcher at the School of Computer Science and Applied Mathematics at the University of Witwatersrand. Is that correct? Sorry about that. South Africa, where he collaborates and supervises students in natural language processing and robotics research. He has a PhD in computational intelligence from Tokyo Institute of Technology in Japan, MSc Robotics and BSc Control Engineering in Electrical Engineering from the University of Cape Town, South Africa. He's also a member of the working group commissioned by the Department of Science and Innovation, DSI of South Africa, on recommendations towards the development of a national artificial strategy of South Africa led by the National Advisory Council on Innovation, where he serves as the chair of the Research and Innovation Subcommittee. Can we please welcome Dr. Makondo to the podium?
Right. Thank you for the invitation and that introduction. So I found that I've spent a lot of time having to correct people on how to say my name, all the way from Venda to Cape Town in South Africa and Japan, and now also working for IBM with Americans. So my name has evolved many times. I'm also having to correct the pronunciation of Wits University to various people. They typically say Wits, so it's an Afrikaans name. All right, thanks for having me again today after yesterday's session. So as said in the introduction, I'm a research manager at IBM Research Africa in Johannesburg, and also visiting researcher at Wits University. So my plan is to narrate my career journey on a timeline, and hopefully there are some lessons learned that some of you can relate to. So I'll also talk about the ecosystem as I go at every phase of my career journey. So I started my career as an electrical engineer, specializing more in control system. I think before that, all I wanted to do was get a degree, go get a job, until I did a mini research project where I was looking at modeling physical systems and deriving control algorithms to actually control them. So I enjoyed that so much that I wanted to do more of that. So I decided to enroll for a master's degree, working with the Council for Scientific and Industrial Research, where I was specifically looking at mining robotics. So the goal here was to have robots autonomously navigate into dangerous environments and perform safe inspections. So I specifically focused on developing algorithms for planning and control of robot manipulators, more specifically mobile manipulators, which is a mobile robot that has an arm attached to it that needs to move around and do safety inspections in the mine. So after this, I went to Japan. You want to do robotics, best places is Japan. Here I focus more on machine learning for robot control. So in my previous projects, I was looking at what now will be called classical AI and robotics. So I was looking at how we can start applying machine learning to learn control algorithms from observed data so we can control the robots. And I think this is where I started really appreciating the value of having domain expertise. So I had this expertise on modeling robots, but now I was applying AI and machine learning into that space. So I worked on various topics, having robots learn from human interaction. And then also a topic I found very interesting was in developmental robotics, where the goal was to take ideas from child development psychology on how infants learn or acquire motor skills and sort of apply that to how we can get robots that learn motor skills from explorations of the environment. After my PhD, I really enjoyed doing robotics research in the lab, but started having this burning passion to make real world impact. So I rejoined the CSR as a robotics researcher. I was looking more into field robotics, where we're looking to deploy robots in unstructured and dynamic environments. So typically you have robots isolated in cages, away from humans, where every object and locations are clearly marked. So we wanted robots that could autonomously navigate and learn to interact with humans in a collaborative fashion. And these are some of the tools that I worked with over time. Then in around 2019, I got an opportunity to join IBM Research in Johannesburg as a research scientist, where I worked on several projects, but I'll just mention a few here. So one of the projects is where I started really applying AI and machine learning into domains I'm not familiar with. And this really gave me the appreciation to collaborate with domain experts in order to have real world impact. So one of the projects was on using machine learning to do groundwater level forecasting, based on weather data. And I remember working with some of the interns where we make some predictions and we got some graphs that look random. I didn't know how to interpret that. But when we sat with the hydrologist, they were actually able to interpret those graphs. And that sort of just solidifies this idea that in order to have real world impact in some domain, you actually have to have this collaborative nature with domain experts. And I started thinking, I think I'm just going to call myself a domain agnostic AI researcher, because I don't think I'll have the capacity to upskill in every domain I would like to apply AI in. So I'll just focus on developing deep skills in AI and collaborating with domain experts to have impact in various domains. I also worked on reinforcement learning for public health. This was around 2019, before COVID, where we're looking at optimizing disease models. So these are dynamic models. To me, they just look like the dynamics of some system that need to be controlled. Which takes me back to control engineering. And we're looking at developing optimal interventions, looking at malaria, but then during COVID, then COVID became very popular, so started looking at that. So also co-supervised a master's student at UCT that looked at different reinforcement algorithms for COVID-19 interventions. Then around 2020 going forward, spent a couple of years, around 2 to 3 years, looking at this, looking at making advances or foundational advances in AI. So here we're looking at bridging the old symbolic AI with neural networks in order to address some of the limitations that neural networks have, such as the lack of interpretability, the lack of generalization outside the training data. So we're looking at developing like the next generation AI systems within IBM research that combine ideas from different AI fields. And we made several advances, publications, patents in this area, and also open sourced some neurosymbolic AI libraries, and also organized some workshops at conferences. And I think the most important thing was IBM at this time was at the center of actually driving this, the scientific community around the idea of neurosymbolic AI. And this was before ChatGPT, came about. And then ChatGPT happened. So we sort of have to rethink how we do research specifically to have business impact. So at the same time, I became a research manager at IBM Research. So I transitioned from being an individual technical contributor to now leading and managing a team of scientists and engineers to develop AI capabilities for IBM Research. So around the time ChatGPT came about, the focus became how to augment LLMs and foundation models more generally for business or enterprise settings, because IBM is always about business to business platforms and products. So there's various projects that we've done on that. And more recently, this work on having LLMs as natural language interfaces to data management systems, such that you can democratize access to data without requiring technical skills. And we also partnered with Madiva on using our NLP expertise to develop biomedical text analysis tools so we can help in the analysis of verbal autopsy. So Madiva is one of the research hubs here at DSI Africa. And lastly, I've also been involved in community engagement and also engaging with the South African government, especially when it comes to developing national AI strategies for the country. Also been involved in organizing workshops and conferences around AI, robotics, and automation. So we have organized workshops at the Deep Learning Indaba, so it's a Robot Learning in Africa workshop for the second year now in Senegal. And recently we organized the first IEEE Robotics and Automation affiliated conference on African soil at Wits University. And we're having discussions to actually expand this so we can have multiple satellite events in multiple African countries going forward. And there are several other conferences. And I think with that, thank you.
Thank you, Dr. Makondo. Ladies and gentlemen, I have the privilege of inviting our last speaker for the session. He's Dr. Ronald Galiwango. Dr. Ronald Galiwango is the Deputy Director and a resident bioinformatics data scientist at the African Center of Excellence in Bioinformatics and Data Intensive Sciences at the Infectious Diseases Institute in Makerere University. His interest lies in using quantitative methodologies to answer epidemiology research questions, as well as biomedical and public health problems with a focus on antimicrobial resistance. This involves innovative in silico approaches for designing antimicrobial drug combination therapies, employing bioinformatics techniques to identify One Health AMR transmission pathways, and utilizing data science methodologies to guide antimicrobial stewardship initiatives. He also has a strong passion for training and mentorship. Having benefited from both, he believes in building a critical mass of quantitative scientists so as to redress the capacity gap and to perform and complete projects with immediate relevance to national and regional health issues. He is on the Training Management Committee and is a mentor on an NIH-funded data science training program under the DSI Africa Initiative MacData, based at Makerere University. He is a data scientist on the Uganda node of the Elwazi ODSP project under the DSI Africa. With this, allow me to welcome Dr. Ronald Galiwango.
All right. Good morning, everyone, and thanks, Mariam, for that kind introduction. So when I was asked to give a presentation on this, I think, very important session, I was thinking about how best, for example, the young scientists out there can benefit from the infrastructure that we have, but also maybe share my experiences on the kind of infrastructure that we possess that I'll talk about that has actually benefited me and the rest of the individuals at the institute where I work. And as Mariam has said, I work at the African Center of Excellence in Bioinformatics and Data Intensive Sciences. I'd like to recognize the presence of the Director of the Office of Cyber Infrastructure and Computational Biology, Mike Tatakoski here, and also the President of RDCT, Chris Wellen, who is helping us to build the infrastructure at the S. So with that, I would like to start on the presentation. Yeah, so this is my career journey in brief, so how it all started. Maybe just to give you some insights here before I start. So I'm going to be giving my experiences and how I think maybe it can be replicated, maybe it can help someone. So I started with a bachelor's in mathematics and statistics from Makerere University. I was very passionate about using numbers and mathematical insights to solve problems. But then something that intrigued me was the application of then biomathematics in this field, things to do with mathematical modeling and how it can actually improve can improve patient outcomes. So it was during my third year at Makerere University that I decided to go for internship at the Uganda Virus Research Institute, particularly the MRC, section of the UVRI. And there I was introduced to biomedical research, coming from a mathematician, coming from a mathematician to now biomedical research. It was an interesting, experience. And then I got to be introduced to possibilities of applying mathematics directly to the medical field. But then I want to highlight here that that's when I was introduced to bioinformatics and computational biology under the guidance of Professor John Chitaimba, who is working at the Uganda Christian University as the Deputy Vice Chancellor, Academic Affairs. So I rotated in the various MRC units and labs. So I want to note here that even though individuals are generally maybe quantitative in nature, they actually need that experience. So you need to first of all throw people into the deep end to understand how data is generated, because they can actually then understand some of the things they will see. For example, if you are talking about data science and machine learning, some of the biases start from there. So I would like to highlight here the EMABS clinic, which was the Entebbe Mother and Baby Study clinic. And there was a study there on asthma that I'll talk about. But I rotated in so many other units, including the labs, the basic science and co-infections, and learned a lot. So now the picture was there. So it was at that time that there was a big issue back then. Maybe now things have improved, but there was no African spirometer calculator for, for school children. So all the tools we're using were sort of like imported from elsewhere. And probably this group knows better that, data needs to be from that locality on which you're training the models, for example. So what we did with a colleague who is also called Ronald, that's why the tool was called R2, because both of us are Ronalds. Yeah, so we developed a local solution which was trained on African data, to try and, predict, spirometry measurements. For example, the peak expiratory flow, the first vital capacity, and the first expiratory volume in 1 second. And it was a success. So which we presented at then the student intern competition in 2013. So you see Professor Allison there and Dr. Rebecca Nsuga giving us the first prize. So this is where it all started. So from there on, we had to do a strategic internship, that was moving from the general approach that we had. So we then started doing, something that was focused on bioinformatics specifically, because that's where my interest, was at the time. And so we did so many trainings, and I think, the importance of the introduction to bioinformatics courses is understated, because so many students and researchers in Africa who didn't have probably learned bioinformatics if it weren't for those courses. For example, those ones that were running under H3 Africa. So I think this should continue. So we started applying for, the different courses, because at the time, I think there was no program in bioinformatics on the continent, apart from South Africa, which I also tried to apply. But in the region, those courses were not there. Of course, I had to look for one of the best options, and I was admitted at the University of Cambridge to do an MPhil in computational biology in 2015, and 2 scholarships, the Commonwealth Fellowship and the Trust Scholarship. So again, so many individuals in our setting, talented individuals who would be nowhere if it weren't for these, scholarship opportunities that are available. So my project was on developing a method to explore fatty acid profiles from ethnologic data. And that's the class of 2015. Those are my colleagues. Can see me there. I'm not hiding, but yeah, I'm right there. Yeah, so it was funded by, like I said, the Commonwealth and the Trust Fellowship. And from then, I think I remember the time when I just finished, I thought I had a lot of knowledge that I had to apply. Of course, I went back home immediately and started, getting involved in so many other projects. For example, modeling transmission dynamics of malaria in high-risk communities like fisherfolk and sex workers, etc. But then also got involved in clinical trials, like analyzing data from large immunological, profiles. But then I was like, I think I need to first of all do this work. And then as fate would have it, there was an opportunity that I couldn't turn down, which was a PhD in computational epidemiology under the guidance of another Chris Wellen, who is at the University of Georgia. And it was epidemiology and bioinformatics. So Go Dogs. And it was funded by NIH. I forgot the PhD fellowship, where I was trying to understand community TB transmission. So if you don't know about TB, it's general knowledge that the household of a TB case is an intense area of transmission. But what is interesting is that actually, if you look at the general picture, most of the cases are not coming from the household. So we've been grappling to answer that question. And we think we are close now. So at the time during my PhD, I was trying to sort of like add information on, that region there that you see that has 30%. That 30%, we just added it in my PhD, and the 50%, but it was unknown. So what we did was we created a social network of TB cases and matched controls. And then we used machine learning and data science to sort of like pull together all these egocentric social networks of a TB case, their contacts, and the contacts of contacts. And we developed a community network. Actually, this work has evolved over time. And so many publications have resulted, but there's one that is coming up next, where we're trying to implicate the social network of a TB case it's how the structure of a social network actually influences TB transmission. It makes it ideal for MTB to thrive in this setting. So I'll not preempt that work. It will be out soon in Nature Communications. So while at my PhD, and I want to emphasize this, there's a lot of work that you're doing. You're really very busy, but it's actually important to look elsewhere, like see what else is happening in that setting. So that's why I got introduced to data science. So it was self-taught under DataCap. So they have a very good program. I'm not their campaign manager, but they have a good data science program that, at the time I think it was free, but nowadays you pay a certain amount of money. But if you're a student, you could benefit entirely from the premium benefits. So that's why I got introduced to data science and data science track. And most of the data science I learned back then was via that. Of course, I also learned data science and statistics. So having completed the PhD, so I got involved in so many initiatives. You remember the time now, this is 2019, just before COVID. So remember that. So we co-founded the Center for Computational Biology, which was a group of individuals on the continent that were trying to sort of like put together the expertise to try and address the challenges that we have in our setting. So we responded to COVID-19 through modeling. So we co-authored various manuscripts and blogs and wrote so many policy briefs that actually helped to shape the policy towards COVID-19 in our setting. Of course, I started teaching on the MSc PhD Bioinformatics program at Makerere University, and I did a couple of postdocs. So the first one, most of them, actually all of them NIH funded, but the first one was under Brecker. And there we did a couple of interesting things, including trying to address one of the challenges that we have in terms of data on movement, because of the ethical challenges. So we thought we could use ground monitored air quality data, as a proxy for movement, and hence a proxy for transmission of infectious diseases, because we know once people are moving, infectious diseases are being transmitted in general. So thereafter, I did another postdoc on HIV and co-infections, which was trying to understand and explore longitudinal viral trajectories of HIV patients, leveraging the large resource of data that we have at IDI that I'll talk about, which is a cohort of over 20 years. So many patients that have been accrued over time and their data safely stored and leveraged. So thereafter, of course, I joined the African Center of Excellence in Bioinformatics and Data Intensive Sciences as a bioinformatician or a bioinformatics scientist. And I'm currently the deputy director. And also the director is here, Dr. Jingo Daudi, but also other colleagues around here. There's Grace, there's Alfred, there's Timothy and others. Then there's also Shahid. And so many others actually listening in online. So, all right, so I just wanted to tell you about what we do at the S. So our mission is to be a sustainable research center of excellence that leverages research training and computational biology to enhance health in Africa. So I highlight 4 or 5 competencies there. Yes, that of the things that we are doing. So we do bioinformatics, we do high performance computing, health data science and modeling, and enhanced visualization. And at the center of it, we have training because of the importance of training. So in the interest of time, I'll just tell you about the HPC on this slide and how it has actually, supported so many research initiatives, including the National Sickle Cell Registry that the HPC hosts, and so many others. So you see under research, I highlight 3 thematic areas. We have microbial resistance, AI and data science, and human genomics and cancer. And just for AI, I'll highlight where we're transforming pandemic guidelines in the country into sort of like a conversational tool that individuals in the field can use using large language models. And also we are doing some other initiatives like data curation and creating a data catalog and also developing a comprehensive data warehouse. A lot about training. So the master's and PhD program in bioinformatics is now in its 6th cohort. And you can see several students have been identified, have graduated and also And actually, I don't want to call it stealing, but they are on market. So we would have wanted to retain some of them, but as soon as they finish, people take them up. So probably it's a good training program. So we also do some short-term training, like supporting the H3 Bionet Introduction Bioinformatics course. We have a virtual classroom. And also we do strategic internships. Remember where I started? So I still have that. I think it's a good way, to support. So I want to highlight the She Data Science program that is supporting Ugandan females and enhancing their data science skills. So we've recruited a couple of master's and PhD students supported by that program. But also we hosted progenic risk course. We had one in June 2024 and the bioimage analysis workshop. And I would like to say all these wouldn't have been possible if it was not the infrastructure that we have at the S. So we've actually talked about how we did this. So there's some papers I've put there, how we are doing this structured training and also the other types of training. So those are images for the different types of courses that we do at the S. So in the interest of time, I just want to end on this note. So we have, in terms of AMR data science, because that's the thematic area that I lead. So we have an AMR computational working group where we're investigating, combination drug design using data science approaches, because the combinatorial space of antibiotics is so large that you need data science tools to try and narrow down the combinatorial space. But also, we know it takes a long time to develop antibiotics, to pass through all that process of approval. So we want to sort of like help that team into seeing which antibiotics can be used in the light of antimicrobial resistance. So we have a team there of students who are trying to look at that, again, powered by the infrastructure we have at the S. So we also do other AMR projects. For example, there's a continent-wide, a global consortium called Carbonet, the Centers for Antimicrobial Optimization Network, where we're building a data warehouse for antimicrobial use and consumption data. But also we've added in some economic data because policymakers need numbers to work with. So we're also developing machine learning models for predicting clinical outcomes of patients with bacterial infections. Also, we have a new collaboration with our colleagues at NIH Cambodia, trying to support the bioinformatics, component of their work. So those publications, actually, most of them are new in terms of the work that we are doing under AMR. So like I said, this is the last thing. So that's the working group that we have. So many students doing different projects, all supported by the infrastructure that we have. So in case you missed my presentation, of course, I talked about the pandemic preparedness work that we are doing. But I wanted to say, in case you missed my presentation, maybe you're doing something, the take-home message is that you have to build partnerships and you need infrastructure and training. So you must have a deliberate training program to support, these budding scientists. And also you don't leave them, you continue supporting them. And that's what the SY work represents. So those are our collaborators and funders. And thank you very much all for listening. Thank you.
Thank you, Dr. Ronald. That was quite impressive. At this point in time, we are over the hour, but if I would go through Rolanda, would it be okay to add us some few minutes? Thank you. So I would like to invite back the speakers to the podium because we've prepared some few questions for you. Also, as a kind reminder, would you please scan the QR codes on your tables to register your attendance today? Thank you. In the interest of time, we won't be taking any questions from the audience. but bear with us. I believe the questions that we have here would try to answer some of your questions. Also, the speakers will be available so you can later catch up with them during the breakout sessions. To begin with, I'll address my question to Professor Benjamin Aribisala. I appreciated in one of your slides, you talk about quiet time and thinking. And with the pressure to publish more, especially for early career researchers, has the art of deep thinking in science been lost? And if so, how can we bring genuine curiosity and critical thinking back into the research process?
Thank you very much. So, genuine thinking, I will say that to bring that into research, in the first thing, one of the attributes of scientists is that curiosity. So the question of how, why, and so for everything we say, we don't just take it. So for early career researchers, you have done a particular review, you compared some papers in literature, and there is maybe a conclusion that says one system or one model is better than the other, but you need to know why. Why is this one better and in what particular context? And actually the word better, scientifically, sometimes we critique it. What does it mean? Is it better in speed? Is it better in rigor? So early career researchers or generally scientists should not just take yes for an answer, but you want to know why is that particular solution correct. So that would be what I will make as a comment for now, yes.
Thank you very much. So it's important to know the why behind doing everything.
That's
Thank you.
correct, yes.
I'll invite my co-facilitator to present the next question.
Thank you, Miriam. My next question is directed to Dr. Tegali. We're talking about diversity and inclusion. We did a little research, and then we saw in the MS magazine that says as of 2021, that only 15% of women are in data science. So that question cropped up, and we are looking at it like, what can be done? What can you do? Or what do you think should be put in place to make sure that we have much more women in the data science field? Then I'm going to make it a two-in-one question. Then what unique strategies can the young women, or can you give to the young women or young early career researchers also in science to employ to distinguish themselves in the field of data science? Thank you.
Thank you for the question. Maybe I'd like to push back on that. Is that really true in Africa? I feel like there's more women in data science in Africa. But that's a very good question, actually. And we should be doing everything we can to promote more diversity and gender balance in computational fields. One of the things we can do is talk about it like we are doing now, and this can empower and inspire young scientist women, and also remove the barrier and the intimidation by seeing other women on the podium that started out like early career researchers like them. And then I think we need to really strengthen the mentorship programs and find really strong women data scientists as mentors for early career researchers, again, to remove the intimidation and the barriers towards entering this field. And then as established researchers, we need to encourage young women to apply for awards or nominate them for awards that can really build confidence. And with confidence, I think early career researchers can really push themselves. And then some strategies for your second question. I think, as the professor said, that data science is not just about coding. I think you really have to understand the field. If you think you're not that good at coding, really lean to the other aspects of data science, which is the creativity to build really communicative, maybe data visualization, which maybe sometimes women are better at, but also how to communicate your results and really make sure that what you're presenting is correct, because often like my mentor, Professor Tulio, usually tells me is that some incredible results can actually be wrong because the data is wrong and it looks exceptional, but just because it's wrong. So really focus on data quality and understanding that all your statistics match up in the end and really understand the field. This can all really help towards data science. And then also, sorry, just looking at, and then, yeah, to be curious, to read papers even outside of your field, because as someone said, data science is really overarching. So you can get a lot of ideas and inspiration from reading papers broadly and attending workshops that are outside of your field. And this can bring an innovative data analysis aspect to what you're doing. And then, yeah, collaborations and really challenging yourself. And then when you overcome these challenges, this really brings confidence. And for early career researchers, that can really help to set you apart.
Thank you, Dr. Tagali. I think I love the answer because I think I was talking to my colleague yesterday and I said, I'm sorry, I'm a man also. And I said, I think it's time for the women to rule. We've been having African leaders that are men and nothing has happened in Africa. So let's give a chance to the women and see what will happen also. Thank you.
Our next question is to Professor Makondo. Do you think that the various academic projects being done now are scalable to industry? And why should early career researchers really care about entrepreneurship?
All right, thank you. And that's two questions in one. Yeah, so the first one about academic projects scaling to industry. I think they can. It is, I guess, difficult to quantify, the rate of, I guess, technology transfer. But I think communities like this at DSI Africa is a step towards that because of collaborations and partnerships at scale. I think what I will add to that is to think about adoption from the beginning, and engage with the end users from the get-go, so that we are able to quickly iterate and refine and actually make sure that we are addressing the real world requirements. And yeah, I think there might be some lessons to be learned from, I guess, industrial research labs whose mandate is actually to develop capabilities for the business. So there's actually a whole ecosystem that goes from fundamental research, development, product development, all the way to adoption. And it is a very comprehensive framework that actually enables, well, it provides like a roadmap for products and enables researchers to focus on those capabilities. And I think also the tech space has been evolving over time. So internally at IBM, we have this program where we upskill research scientists on software engineering skills, so that researchers actually deliver software components in addition to their publications, such that it's easier to integrate this into platforms and products. The second question is about entrepreneurship. Why early career researchers should care about entrepreneurship? I think there's a need to transform scientific discoveries into businesses, successful business and ventures that address real world problems. And I think as researchers, we understand these advances in science. I don't think anyone else understands that. So I think it'll be difficult to expect entrepreneurs without the scientific training to be able to transform these discoveries into business and science and real world impact. And I think also some of the successful researchers actually have the entrepreneurship mindset and behavior, because you need the ability to source funding. You need the passion and need to make real world impact. So you're not just driven by publications, but you actually want to see scientific advances having real world impact. And you also need to be able to communicate scientific outputs to different stakeholders. So entrepreneurs really need to do that. So, and I think having that as an early career researcher will actually, accelerate your career trajectory.
I think science is a business, and knowing how to sell and attract buyers is also important. So thank you for the insights.
Next question is directed to Dr. Joyce. My question is, what advice, if you have your younger self standing in front of you now, what advice would you give to your younger self about finding and valuing a mentorship? And what role can mentorship play in research training in Africa? Thank you.
Thanks. What would I tell my younger self? Do not be afraid. I think seek out for a mentor, someone who inspires you. And I think since it's a younger self was female, again, I would say do not be afraid, you can make it. I don't know if that answers it. Yeah. And then the next question was, what role I think does mentorship play? Is that the question?
Yes.
Okay. Yeah, the role that I think mentorship plays. I think mentorship is important because it helps to, I think, provide the space for early career scientists to seek out, maybe in the areas that they're not very knowledgeable about, in the territories that they haven't gone before, but their mentors have gone on before, just to help them to understand this, to help them in maybe problem solving and providing these insights that they might not be aware about. So I think seeking a mentor and trying to follow through with that mentorship plan that you have with them, I think is really, really important, because it helps to open up your world to things that you do not know, but also to kind of like a hand-holding. I know that's like an important thing, that we're hand-holding in science, which sometimes is not, it's maybe something that the early career scientists are afraid of. And I think the mentors really, really help to accelerate them along their journey. So I think that's maybe the role of mentorship. Yeah, thanks.
Thank you.
Our last question is to Dr. Ronald. We've had this saying that data is the new oil, but do you think all data is valuable?
That's an interesting one. It's probably a question to everyone in the audience. Yeah, but I really like that analogy of data being the new oil, because there's also a mining process for data. So things like data collection, data processing, and also, quality assurance. So again, yeah, all data is valuable, although probably it may tell you things you don't want to hear, but it's actually valuable. So, that transformative, potential of data. So we need to sort of like explore it and then also like use it, to try and inform decisions. Because without data, what are we doing? So we have to use the data that we have, but also in that data, we can inform the now, but also the future. So yes, data is valuable.
Thank you very much. And with this, this brings us to the close of our session. Please join me in giving a hand of applause to our speakers. And would you kindly give a hand of applause to yourselves for being patient with us at the time? And we would like to thank all the early career researchers for trusting us to take on this role. Not an easy one, but thank you. And thank you so much to all our guest speakers. Rolanda, do you?
All right, thanks everyone. And thanks Miriam and Wally for moderating the session. So there's a refreshment break now. The break is on the Sky Deck, but please also make your way to the poster session right now. It's the other set of early career researchers displaying their posters on the LCD screen.